Disaccharides are formed upon the reaction of two monosaccharides. So the di means two. So we have monosaccharide reacting with another monosaccharide to form disaccharides. This is a condensation reaction wherein, aside from the disaccharides being formed, water molecule is also formed because it was removed from the reaction of the two monosaccharides. Now, what binds these two monosaccharides is known to be the glycosidic linkage. So, this is the bond that binds the two monosaccharides together, and this is resulting from the reaction of the hemiacetal carbon atom hydroxyl group from one monosaccharide and the hydroxyl group of another monosaccharide. So, paano ito? The glycosidic linkage happens with the hemiacetal. So, dun sa Hayworth's natin, alam natin that this carbon number 1 of the first monosaccharide is the hemiacetal carbon atom or the anomeric carbon atom. So, yung hydroxyl daw na yan, okay, magre-react siya with another hydroxyl coming from that second monosaccharide. So this is the reaction between the hydroxyl of that hemiacetal carbon atom and the hydroxyl of the other monosaccharide, such that, okay, yung hydrogen dito sa first monosaccharide will react with the hydroxyl. That's why you're going to have the HOH or H2O. So, yung H2O na yan ay HOH. The H is coming from the first monosaccharide and the hydroxyl is coming from the second monosaccharide. Okay? And then that oxygen will be now linking to this carbon atom of the second monosaccharide. So, dito sila mag-form. So, this one would be the site of reaction. Okay? And this oxygen linking to other carbon atom is known as, so this is linked to that first carbon atom and this is linked to this third carbon atom of the second monosaccharide. And ang tawag dyan ay glycosidic linkage. Okay? This reaction, so if we start with the two monosaccharide, so this is monosaccharide 1 and that's monosaccharide 2. Okay? The forward reaction is known to be the condensation reaction wherein a disaccharide was formed together with water molecule. However, this is a reversible reaction, so pwedeng pabaliktad din. We start with the disaccharide, lagyan ng water molecule, it's known as hydrolysis. At ang mafo-form naman ay, so pabalik, are two monosaccharides unit. Okay? So, disaccharides can be easily hydrolyzed, so yun yung hydrolysis kanina, which is the reverse of condensation reaction. But of course, this requires enzymes or alkaline catalysts. Okay? We are going to discuss 4 different disaccharides, namely maltose, and then we have cellobiose, then we have lactose, and sucrose. Okay, so let's differentiate one from the other. Okay, maltose is also known as malt sugar since it is found, it is the starch that, it was the sugar that produced when the starch breaks down. So, kapag nag-germinate na yung mga seeds or during start digestion, maltose will be produced. When you say malt, these are actually a germinated barley. Okay? And ano ba yung may mga malt? Usually, yung mga beer, they are made of malt. Tapos may mga energy drinks din na merong contain ng malt. Okay? Nevertheless, the sugar that could be found in malt are maltoses. The disaccharide maltose is composed of two D-glucose units daw. So, it's a right-handed glucose units kasi D-glucose units into which ang requirement ay yung dapat isang D-glucose ay alpha. Alpha D-glucose. Paano yung alpha? Yung hydroxyl on the terminal carbon atom or the terminal CH2OH, and the hydroxyl group on the anomeric carbon atom should be in opposite direction for that to be an alpha. Okay? At ang type ng glycosidic linkage daw niya ay alpha 1 to 4. For maltase to be hydrolyzed, to be converted back to its monosaccharides, it requires an enzyme maltase. So, si maltase lang ang makakapag-breakdown ng maltose into its forming monosaccharides, the 2D-glucose units. So, paano na-form ang maltose? So, sabi natin kanina, kailangan ng dalawang D-glucose. So, ito yung dalawang D-glucose. At ang isa pang requirement, yung isang D-glucose daw should be an alpha. So, alpha D-glucose reacting with another D-glucose. Paano naging alpha ito? Kasi ang terminal CH2OH at ang OH in the anomeric carbon atom are in opposite direction. The one is on top and this one is at the bottom. Okay? So, it will react with the D-glucose. So, alam natin that glycosidic linkage happens between the anomeric carbon atom of the first monosaccharide and the fourth carbon atom of the second monosaccharide. So, the hydroxyl coming from the first, itong blue, coming from the hydrogen of the hydroxyl group of the first monosaccharide will react with the hydroxyl of the fourth carbon atom in the second monosaccharide. So, they are going to form water. And then, syempre, kapag wala na yung hydrogen dito sa may hydroxyl group, magkakaroon ng free bond for oxygen. So, that free bond will be connected to the fourth carbon atom. Okay, dahil dyan, it is known as the alpha 1 to 4 because this is an alpha unit. Okay, and the bond happens between the one or the first carbon atom of the first monosaccharide and the fourth carbon of the second monosaccharide. That's why it is alpha 1 to 4 linkage. Now, as you can see, for the formation of disaccharide, particularly this maltose, so ito na yung buong maltose unit natin. Okay? We involve two disaccharides, so dalawa yung pinag-react natin kanina, and only one anomeric carbon atom or hemiacetal carbon atom is involved in the reaction. Ito lang ang involved. Itong hemiacetal carbon atom ng second monosaccharide, hindi siya involved sa reaction. So, dahil hindi siya nga involved, meron pa rin ang possibility that an alpha or beta maltose could exist. Okay? So, ulitin natin, only one hemiacetal carbon atom is involved in the condensation reaction of these two monosaccharides. So, therefore, the possibility for an anomeric maltose or anomeric disaccharide in the form of alpha and beta is possible to exist. Kasi ito pwede pa rin siya oriented above, so that would be beta, or it could be oriented below. So this one could be oriented below such that it is in opposite direction with the hydroxyl group, so therefore it could be an alpha. Okay? So, pwedeng magkaroon ng alpha maltose if the hydroxyl is oriented down, since the terminal hydroxyl is above. Dapat opposite. And beta maltose could exist if the hydroxyl in this anomeric carbon atom is oriented above, so that both of the terminal CH2OH and the hydroxyl are oriented on the same direction. Okay. Nevertheless, this is the maltose. It has an alpha 1 to 4 glycosidic linkage. Next would be the cellobiose. This is an intermediate in the hydrolysis of cellulose. So, pag na-breakdown yung mga monomers dun sa cellulose, the disaccharides that would be formed is cellobiose. Okay. Just like glucose, cellobiose needs 2D-glucose. So, parehas silang nangangailangan ng D-glucose. However, the requirement for cellobiose, one monosaccharide should be a beta D-glucose unit. So, kung kanina kay maltose ay alpha D-glucose, ang requirement niya, dito naman kay cellobiose, kailangan karoon ng beta D-glucose. Nevertheless, ang mechanism ganun pa rin, the hydroxyl or the hydrogen in the hydroxyl ion of this first carbon atom in this first monosaccharide will be reacting with the hydroxyl ion on the fourth carbon atom of that second monosaccharide. Okay, still water will be produced here because of the reaction of the hydrogen and the hydroxyl. However, for this case, it's no longer alpha 1 to 4 linkage, rather it would be a beta kasi ang starting material natin dito is a beta D-glucose. So, medyo pataas. So, you could actually differentiate alpha 1 to 4 from beta 1 to 4 because of the structure. So, yung alpha 1 to 4 kanina ay, so parang ito pag ay yung dalawang bond going down and you have your oxygen. So, yan. Okay, so pababa. Parang magkahawak sila dyan. Dito naman, pagdating kay beta 1 to 4, so yung isa pataas and then oxygen and then going to the right. Parang ganan. Upper right. So, hindi sila pantay. Okay? So, ganun din sa cellobiose, only one hemiacetal carbon atom is involved in the condensation reaction. So therefore, itong remaining hemiacetal ng second monosaccharide ay free pa rin. So an alpha and beta anomer is possible to exist for cellobiose. Okay, kasi ito pwede siyang oriented above and pwede rin maging oriented below, so that we could have the alpha and beta anomers. Okay? So for the next one is lactose. Lactose is the major sugar that could be found in milk, hence it is known as the milk sugar. For this case, the monosaccharide needed is D-glucose pa rin, but ang kasama na niya ay si beta D-galactose. Remember, dun sa discussion natin ng monosaccharide, galactose is seldomly free in nature. So, hindi siya nakakapag-isa. So, kailangan niyang sumama with other substances. So, for lactose, ang galactose at ang glucose ay magkasama. Okay, so ang kanyang glycosidic linkage is beta 1 to 4 because if this is beta D galactose, so the first carbon atom, the hydrogen in the hydroxyl of the first carbon atom of the beta D galactose will react with the hydroxyl on the fourth carbon atom of the D glucose. So, and beta 1 to 4 glycosidic linkage will be formed. And of course, after the reaction, meron pa rin tayong side product na water. Okay? So, the souring of milk is caused by the conversion of this lactose into lactic acid, and the enzyme that could break down lactose is eventually lactase. Okay? Kanina ang enzyme for cellobiose, balikan lang natin ito. The cellobiose could not be digested by humans because or by yeast because we lack the enzyme cellobiase to act upon it. Okay? However, for lactose and maltose, we have their enzyme, so we could actually digest lactose and maltose. Okay? So lactose is the principal carbohydrate in the milk, and human milk or human mother's milk is obtained by the nursing infants, contains 7 to 8% lactose ang mother's milk. However, yung mga formula lang daw or the cow's milk ay 4 to 5% only. That's why laging ina-advise that mother's milk is still best for the infants. Okay. We have condition known as lactose intolerance. So ito yung condition into which hindi makadigest yung mga tao if they could not digest the milk because these people lacks the enzyme lactase. So wala silang lactase for that lactose to be converted to galactose and D-glucose. So ang nangyayari if they could not digest the lactose that could be found in milk, usually they suffer the fullness, discomfort, so they have nausea, cramping, and diarrhea. Okay, so we have reasons why one person will suffer from lactose intolerance. It could either be because of the deficiency of lactase, and that could be caused by the genetic defect, so namamana. So lactase also decline with an age. So habang tumatanda, the lactase in our body is nagde-decline. And also, the deficiency of lactase for a certain person could be caused by the injuries in the mucosal lining in the intestine. So, may mga reasons kung bakit ang isang tao ay nagsasuffer from lactose intolerance dahil at maraming reason din kung bakit nawawala yung lactase sa katawan natin. Okay? So let us be reminded that lactose intolerance is not a food allergy situation. Rather, it's just a lacking of enzyme. So hindi siya mako-consider na allergic ka sa milk, hindi ganon. Okay? It's just that kulang ka ng enzyme. Okay? Kasi pag sinabing food allergy, ibig sabihin the person's immune system has been invaded by an allergen. Okay? So, it's just that kulang ka lang ng enzyme. Another condition is Galaptosemia. This is a genetic condition in humans caused by the absence of the enzyme that will convert the galactose into glucose. Kasi glucose usually ang ginagamit ng human body. So the galactose, once lactose has been metabolized or has been hydrolyzed to its monomers, glucose and galactose, the galactose has to be converted to glucose again so that it could be used by the body. Now, kahit na meron kang lactase that breaks down this disaccharide into this glucose and galactose, pero kung wala ka rin namang enzyme to convert that galactose to glucose, you're going to suffer from galactosemia. Okay? And this galactosemia could cause mental retardation in infants and death. Okay? Why do we need to convert galactose into glucose? Because once galactose and other metabolic derivatives such as galacticol and dulcitol, okay, if they remain to be unconverted, they will accumulate in the blood. Okay? So, and that is the cause of the mental retardation among infants and even deaths. Okay, another condition is lactase persistence. Yung lactase persistence daw is a condition wherein the drinking ability of human it continues into adulthood. Okay, so lactase persistence, ibig sabihin yung lactase mo sa katawan ay hindi nagdi-diminish because naturally, as you grow old, the lactase should decline. The amount of lactase in your body should decline as you grow old. Pero if matanda ka na and you could still your lactase level is still high, then that's the condition known as the lactase persistence. And the last disaccharide is sucrose, also known as the table sugar. So ito yung meron tayo sa bahay, mga table sugar natin. The monosaccharide present here is an alpha D-glucose and a beta D-fructose. So, ulitin natin kanina, for maltose, you need 2 glucose units. And for cellobiose, still 2 glucose units. For lactose, you have glucose and galactose. And the last, sucrose, you have glucose and fructose. Okay. The glycosidic linkage for sucrose is alpha beta 1 to 2. Okay? So, unlike the first three disaccharides, maltose, cellulobiose, and lactose, this sucrose is a non-reducing sugar. Okay, explain natin bakit non-reducing sugar siya. Wala daw siyang alpha and beta isomers or anomers because the hemiacetal carbon atom or the anomeric carbon atom are actually the one involved in the glycosidic linkage. Okay, so balikan natin. Ito yon. Ano yung sinasabi? Bakit daw hindi pwede ang alpha and beta anomers sa sucrose is because of the reaction of the alpha glucose and the beta fructose, the reaction happens both on the anomeric carbon atom. Okay? Ano yung anomeric carbon atom? Okay, carbon number 1 for alpha glucose and carbon number 2 for beta D glucose. Okay? So, this is an alpha kasi nga the hydroxyl on the anomeric carbon atom is below while as the terminal CH2OH is above. So they are on opposite direction, so therefore that's an alpha. For this naman is beta because the terminal CH2OH is above and the hydroxyl on the anomeric carbon atom number 2 is above also, so therefore they are on the same direction, so they are beta anomer. Okay, glycosidic linkage will be formed between this anomeric or hemiacetal carbon atom, so still the hydrogen and the hydroxyl will go together to form the water. The oxygen will be left so that it will have a bond between, so ito, yung oxygen na yan will have a bond with the second carbon atom. Dahil ang reaction ng glycosidic linkage formation is between the two hemiacetal carbon atom, hindi na pwede ang alpha and beta anomer kasi wala na yung free. Unlike dun sa, balikan natin dito balikan natin si lactose. Meron pa kasi siya ditong free carbon atom or free anomeric carbon atom. So, ito pwede pang maging alpha or pwede pa siyang maging beta. Kasi nga, isa lang yung involved sa glycosidic linkage formation. Okay? Pati din si cellobiose. Itong hemiacetal carbon atom lang na to ang involved. Ito, hindi siya involved. Kaya may possibility pa na magkaroon ng alpha and beta anomers. Pero kay sucrose, hindi pwede kasi both the hemiacetal carbon atoms from the two monosaccharide are involved in the condensation reaction. That's why it is known as the non-reducing sugar. Kasi wala siyang alpha and beta isomers or anomers. Okay, the enzyme that could break down this sucrose is known as sucrase. Okay, also table sugar imposes health problems because of our demand to satisfy our sweet tooth. So scientists were able to find a solution to solve this sucrose problem. Hence, they form sugar substitute. The sugar substitute actually contains the same sweetness, however, they don't impose the same calorie, or eventually they don't impose calories upon the user. Okay? So we have here few sugar substitutes. Okay, we have saccharin, sodium cyclamate. Okay, we have aspartame, sucralose, and neotame. Okay, so ito yung mga sugar substitutes. They possess the same sweetness, but they don't contain the calorie the same amount of calorie as compared to the table sugar. Now, saccharin is the oldest artificial sweetener. However, studies suggested that there's a large dose, using large dose of saccharin could cause bladder tumors in rats. So, meron siyang mga adverse effect kasi hindi naman siya natural. Sodium cyclamate, on the other hand, causes cancer in the laboratory animals. So, because of this, Canada approved the use of because saccharin causes blood tumors in the rat. Canada banned saccharin. However, they approve the use of sodium cyclamate. Aspartame, on the other hand, is 150 times sweeter than the sucrose. Okay, so masyadong sweet ang aspartame. Usually, ginagamit tong aspartame sa mga beverages. Okay? Ang drawback lang ng aspartame and saccharin, they are not heat stable. So, hindi mo siya pwedeng isama if you're going to cook the product. Kasi nagbabago daw siya once heat or once cooking is applied. Also, aspartame contains phenylalanine. So, this is an amino acid that causes mental retardation to children suffering from phenylketonuria or PKU. So, meron siyang phenylalanine. Kaya yung mga products na merong aspartame, nagwa-warning sila na this contains aspartame para malaman ng consumer that it contains phenylalanine. Okay? Sucralose, on the other hand, is 600 times sweeter than a sucrose. So, sobrang mas matamis pa siya as compared sa aspartame. Unlike aspartame, which is not heat stable, sucralose is heat stable. And since they are heat stable, they do not lose the sweetness when heated. It's still calorie free, and however, they could not be hydrolyzed in the digestive tract. And the last sugar substitute is neotame. Neotame is 7,000 times sweeter than a sucrose. It's a general purpose sweetener, and it is heat stable, and it is also safe for those suffering from PKU or phenylketonuria.